Hi everyone, I am Gauri PS, Department of Radiology, Global College of Allied Sciences. Today we are going to discuss about our topic electromagnetic induction. What is electromagnetic induction? Electromagnetic induction is a fundamental concept in physics where an electric current is generated in a conductor due to a change in its magnetic field. We can define it also as an the electromagnetic induction is the process of producing an induced electromotive force across an conductor when it experiences a change in their magnetic flux. Electro Electrostatic induction is also called as it is a phenomenon in which the positive and negative charges are accumulated or separated in a substance when a charged body is brought nearer to it. That is, for example, when a negatively charged body is placed near a conductor, there the nearer end will be acquiring the positive charge and the end which is away from the conductor will be acquiring of what negative charges. So that means that the negative charges will be repelling the electrons to the far end. Therefore, the amount of charge in the both the conductors will be same. If one is positive charge, then it will have then the other will have an opposite effect. This method of charging a body is also called as electrostatic induction and is usually used in machines and capacitors. For example, electrophorus, lightning arrestor, and pantograph generators. Then is Faraday's laws of electromagnetic induction. Actually, in 1831, Michael Faraday he showed that the production of current from a magnetic field. So, according to Faraday, the current can be produced in a closed conductor whenever there is a change in the magnetic flux which is passing through the conductor. The current will be existing only as long as the changes takes place. So the current produced in the conductor will be in this way, and this is called as an induced current. So the electromotive force that produces the current is called as an induced EMF. The whole phenomenon is togetherly called as electromagnetic induction. So Faraday considers some of experiments by which he said that he concluded two laws, that is called as Faraday's laws of electromagnetic induction. So, according to the phenomenon of electromagnetic induction, it states two laws, that is Faraday's two laws. First law is the change in a magnetic flux which is linked with a closed conductor will be inducing an EMF in the conductor. The induced EMF will be existing as long as the change in the magnetic flux continues. So, this is the first law of electromagnetic induction. Next is about second law. The second law states that the magnitude of this induced EMF in a closed conductor will be proportional to the rate of change of magnetic flux which is linked with the circuit to the area of the circuit. So the Faraday's law formula is electromotive force EMF, that is proportional to or equal to minus n d phi by dt. So here the E we say it as EMF, that is induced EMF, and the n is the number of turns and phi is the magnetic flux and t is the time taken. So here there is a negative sign. So the negative signs will be indicating the direction. That is, it is given by the Lenz's law. So, next is about magnetic flux. What is magnetic flux? So, the magnetic flux, that is phi, is linked with the surface, will held in a magnetic field. Usually it will be held in a magnetic field, and it will be defined as the number of magnetic lines of force that is crossing an closed area A. So, if we consider theta is the angle which is between the direction of the field and the normal to the area, then phi is equal to BA cos theta. So, next is about phi is equal to, so we formalize it, magnetic flux phi is equal to BA cos theta. So, next is about Lenz's law. The induced EMF is in such a direction that it always opposes the change of magnetic flux which induces the electromotive force. So the direction of the induced current will be opposes the change that produces it, which ensures the conservation of energy. So, what are the ways we can induce EMF? That is, by moving a conductor in a magnetic field, changing the magnetic field strength, changing the area of the loop, and rotating the conductor, that is, the changing its angle, that is theta. So, next is about applications. So, what are the places where we apply these electromagnetic induction? That is about in electric generators, transformers, induction cooktops, wireless charging, and electric motors. Usually, this direction of the electromotives, that is induced EMF, can be predicted by using the Fleming's right hand rule. Fleming's right hand rule. So, what is Fleming's right hand rule? That is, for applying this rule, we have to stretch the right hand of the of our hand. That is the thumb, forefinger, and the middle finger. That three fingers should be at right angles to each other. So, if the thumb denotes the motion of the conductor, the forefinger denotes the direction of the magnetic field, then the middle finger will be denoting the direction of the induced EMF. So, by this, we can identify the direction by which this induced EMF is passing out throughout the circuit. So, in direction of the induced EMF can be identified by using the Fleming's right hand rule. Then that's all. That's all for today's. Thank you.